I'm Kay Wagner, your host today on behalf of the Mid-Atlantic Precast Concrete chapter, and we are focused on bringing information and education to the Mid-Atlantic region about precast concrete. And today we're doing a video on the project in Harrisburg, PA of the Pennsylvania Housing Finance Agency. And we have with us Benedict Dubbs, who is the architect on the project, and Jamie Sweigart, who is the precast producer from High Concrete, who produced the precast for the project. So Benedict, you want to say a few words and introduce yourself?
My name is Benedict Dubbs. I'm a principal at Murray Associates. We are the design architect for the project.
And we have Jamie Sweigart with us. Jamie, you want to introduce yourself?
Sure. My name is Jamie Sweigart, Regional Sales Manager for High Concrete, and we were the precast providers for the project.
Okay, terrific. Thank you. So Benedict, as the architect, do you want to get us started on this project?
I'd love to. Why don't we go to that first slide and we can look at what the context of the site was prior to the beginning of our design. So we were fortunate enough to work with Brian Hudson, the director, on their original corporate headquarters located at 211 North Front Street. And they came to us with the request for an addition. So we started to work with the local officials, the historical commission, and other city stakeholders to develop a design that would fit contextually within that footprint of the tower expansion, but also a building that would work and look like it was part of the neighborhood. So as we go through some of the images today, you'll see how we've developed a design to respond to a number of different design opportunities. Like I say, another opportunity was to increase the footprint for the building. So we were actually cantilevered a portion of our building over the existing turn of the century an 1800s row home located on Front Street, a very prominent mansion known as the Hickok Mansion. We actually cantilevered a portion of our building over that historic structure to increase the building footprint. So if you'll see that in the rendering to the left, you'll see that there's a portion of our building actually cantilevers over the roof structure of the 1800s building. And then there was an areaway between the 211 building and the Hickok Mansion. We've actually infilled that areaway with some structure, some infrastructure, and now the new tower rises above that courtyard and connects the 211 building with the new vertical tower.
Tell us how you and High got started.
In developing the building facades, it was important that we take some of the architectural language from the 211 building and interject that into the new design. So if you look at the exterior elevations, the building really has a base to it, which is 3 stories in height, which aligns with the rest of the 3-story residential neighborhood. So the base of the building is brick. The entire street and most of a lot of historic buildings in Harrisburg are brick facades. So that base, that's the base of our building. Then going above that, in working with the Historical Commission and a number of other state agencies, they really asked us to develop a building that was more glass. But it was important for us to come back and introduce precast concrete so that contextually we could have some connection back to the 211 PHFA tower. So we have on the prominent facade on the south facade, we have a series of precast concrete panels that utilize very similar language, and Jamie can talk in more detail, but the reveals, the color of the precast concrete is very much respectful of the existing building. So contextually, it was a very nice way of making the new tower and the existing tower be one building, if you will. Certainly the glass is a new introduction, but we wanted to have that contextual connection, that materiality was really important to the overall design.
So Jamie, do you want to address that?
Yeah, exactly. Thank you, Kate. What we tried to do was match as close as possible to the existing building that was there, which was a white or an off-white color. The reveal pattern was very similar to what was there. We also tried to mimic the, I'll say, punched window openings within the panel. So what you see is the windows, if you look at the existing building on the back, or the windows that were part of the punched opening in the precast, and the new facade also has that similar approach with the windows. We also have a picture of our shop drawings, high concrete shop drawings, that we could show you how we detailed. I know it's kind of hard to understand. There's a lot going on in that picture, but this would be actually a snapshot from our drawings that we use to create the panels. From this is how we make our production tickets to pour the piece. But what this is that elevation, and what you'll see is the X's are the openings. Those are actually openings within the panel, which would be called a punched opening type wall panel. And these panels were supported by the structure, the steel structure. It was not a panel that was bearing on a foundation. So this all had to be supported by the structural steel. And on the right side, that skinny vertical element, that is the return panel of the panel on the left, just to the left of that. So we had a monolithic pour that was part of that panel to create the corner element.
And that was really important, Kay. That corner detail was critical, and we worked back and forth with Jamie and his team to develop that. Another critical component to the precast, unlike the 211 building, this is a carbon reinforced, very heavily insulated panel. Knowing that this project is a passive house building and also we're seeking LEED Platinum, that high performance insulation was critical to us, and the ability to eliminate thermal bridging is a key component of any passive house project. So working with Jamie and his team, that's where we really work back and forth in terms of where joints are going to occur, how that insulation can remain continuous, so that we wouldn't have thermal breaks and thermal bridging with connectors and voids within the precast. So we went around several times with sketches and then reviewing things in the shop drawing. And when the panels came out, they went together very, very effortlessly. So it was a very, very smooth installation.
Yeah, Kay, if I can just touch on the insulation properties of that panel. So what we ended up designing, again, working very closely with Murray, back and forth, detailed sketches. The panel ended up being an insulated precast panel, which is a carbon cast panel. So the insulation is within the panel. The carbon cast is actually a shear grid, we call it, which holds both whites of concrete together. So it had an exterior face of 3 inches. Which is the architectural color that you see on the exterior. It had an insulation of 4 inches, which was an XPS insulation around R5 per inch. And then we had a 5-inch back white. 5-inch was a little thicker than normal, but because of the design and the bearing connections, all the connections to tie to the steel, we had to make it a little thicker. So overall, we had a 5, 4, 3, so a 12-inch panel.
So this is what you were talking about in the drawing?
Correct. That would be the return panel.
Correct. Yeah.
Right. Okay. And then this is what we're matching.
Correct.
That's correct. So the building in the background would be the original 211 headquarters building, and then the precast in the foreground is the new precast, the carbon reinforced precast panels. And color wise, it's a very, very, very good match. The reveals, the detailing came out very, very well. It really contextually works, looks really good.
Benedict, correct me if I'm wrong. It was a light sandblast? Is that
correct? Light sandblast finish, correct. And as you mentioned earlier, Jamie, part of the reason why the panels are as thick as they are is we really did have a large ratio of openings in the panel. So it was a bit of a stretch structurally to make some of the rhythm that we created. Your engineering group worked very close with us to adhere to those openings and the punched window. You'll see there's a large kind of penetration that is glass within that field of precast. That window, as we refer to it, is actually a 2-story element. High's precast goes around that and really frames that opening very, very nicely. And that became part of the rhythm as the rest of the streetscape moves vertically and horizontally. It also moves in and out a bit. So we wanted to take that same rhythm and introduce it to the upper portion of the new tower.
And from this angle, Benedict, this is what you were talking about, where you pulled the extension or the expansion out.
Correct.
And
Correct.
It hangs over this?
That's correct. So just to the left of the precast, there's a one entire bay of the building actually cantilevers over the 1800s row home. And that gave us a little more additional square footage, but allowed us to soften that corner a bit. So we gave the whole facade, just created a very nice rhythm as it continues north and connects back into the original tower. With that connection was really important to us and really important to the historic group and some of the other city stakeholders that we were working with to get the approval through city council.
Talk to us, Benedict, about LEED Platinum.
LEED Platinum is the highest level of certification we can achieve through USGBC. In order to do that, you really need to take into account all of the details, all the materials, and really it's difficult certification to achieve because of the high number of points that have to be achieved to get that certification. At the same time, we're also pursuing Passive House, which Passive House is really focusing on the exterior envelope to the greatest degree, while LEED is a holistic approach to a building wellness. Passive House really focuses on energy usage and the building envelope. So here again, working back and forth with Jamie and his team, getting all those details and being able to, as I mentioned earlier, continue that insulation, minimize the joints, minimize thermal transfer, because on the back of all those connections, there's welded connection points. As Jamie mentioned, the load of that precast is actually hung off the structural steel. Jamie and his team work with us to minimize those number of connection points. But with the insulation in between the two panels, we didn't get that thermal bridging. So that's a tremendous energy savings, because today, as we are becoming more building envelope scientists, we understand how cold air moves across the building into the inside of the building, get condensation, and that can sometimes lead to some internal potential problems for the occupants. Now looking at Passive House, we're able to limit that almost to the point where we're having almost virtually zero. It's a better long-term investment for the building because you don't have any potential points of deterioration, and we end up saving a tremendous amount of energy in the process.
Yeah, and if I can add to that, Kay, I mean, we really pride ourselves when we say continuous insulation, and if you would have seen these panels prior to being installed, the insulation does run edge to edge, top to bottom. You would see that exposed insulation at the edge of our precast. Along with that, the carbon fiber is non-conductive, so you do not get any thermal bridging through that panel. And as Benedict said, one of the reasons that back was a little thicker because of those connections, there are instances or some projects where we have to thin up the insulation because we just need more concrete to support or to have that connection. We really didn't want to do that on this job. So we ended up making the back a little thicker to accommodate those connections. But we truly have 4 inches of continuous insulation around the entire precast element or surface.
And that was a key component in our energy modeling and also in the Passive House design, maintaining that high R value.
So Benedict and Jamie, as you look at this project now in its beautiful completion, we'll start with you, Benedict. What are your final thoughts about this project as you look at it now?
Well, we're very proud of the project. The construction is coming to a close. We'll be occupied by PHFA this summer, and we're very proud that the renderings that we developed almost a year and a half ago are still intact. The building has not changed in design. It's been very, very successful. One of the kind of a testaments, if you will, to success is the neighbors love the building. In the beginning, they were skeptical. New construction, and what's it going to look like? How's it going to have impact on us? The glass of the building is actually electrochromatic glass. So instead of having window blinds, the glass actually is the tint of the glass is controlled by a computer. So it will be lighter and it will get darker as the sun hits it. But one of the other aspects is that at the end of the day, in the evening, in the winter, when there's still occupants in the building, PHFA can actually make the glass dark, so you don't get any light pollution into the adjacent neighbors into their residential spaces. So again, there was a great deal of detail, a lot of discussions, a lot of design discussions throughout the entire product to achieve a building that contextually works with PHFA, reinforces PHFA's culture. One of the programs that PHFA has undergone last few years is to, in their multifamily housing, to discuss the use of passive house as a building envelope for energy savings. Mr. Brian Hudson, the director, said he thought that it was important that PHFA take the lead on, if they were going to be promoting this in their multifamily housing, that their billing should also meet that criteria. So he was instrumental in saying, requiring that the billing would be passive house and also be a LEED Platinum, but also be a building that was a good building for the city and for the neighbors. So we're very proud of it, and we've gotten very, very positive comments thus far, and we're very pleased at the results.
Wonderful. And Jamie, when you look at the final shot, what are your thoughts about it?
Yeah, we're very proud of it as well. I mean, it is a limited amount of precast. I know eventually, at one point it was a little larger, but we're certainly proud of it. It is our first passive house project, so it's something that we will certainly promote in the future. And it's just a testament that, precast does offer a lot of versatility with the continuous installation, the R value that we can achieve, the aesthetics that we can achieve. There's a lot, we didn't really touch upon it, but with the LEED Platinum, High Concrete is within 45 miles. So we're very close. Precast also offers additional LEED with recycled material, recycled content. But overall, the project looks great. It is something that High Concrete is proud of, and certainly will be promoting along with Benedict, for future passive house projects. This
is one of the first passive house vertical office buildings in the country. So it is a unique building in many ways, between the context of being in an urban context. The laydown area, there is zero, as Jamie will tell you. They delivered their precast panels, lifted them, and the truck disappeared, and the next set of panels came. So construction was very unique in that there's no laydown area. It really was deliver materials to the building, install them. High did a great job, and their erector did a great job in doing so. Absolutely no damage to panels. They did a great job. But also the fact that it is such a unique building from a passive house product. There are lots of multifamily products, but this, to our knowledge, is one of the only vertical office towers that's a high-rise building. And we were, again, very proud of that, because it does show that between glass and steel and precast concrete, you can develop a building that meets all of the very stringent criteria for both passive house and LEED Platinum, and design a beautiful building. And the precast just complements the tower very, very well.